Well, hello again. I have made a command decision. I love making command decisions. You know, the purpose of this restoration, or any restoration that I do, is not to impress everybody and how well or how poorly I repair and restore radio. The idea here is to help people just starting out, or the older folks that have been around for a while, they would like to have a refresher. And of all of it, I think the schematic, how to follow a schematic and what to look for and everything, that seems to be of prime concern. I know it was for me. When I first started looking at schematics and radios, the schematic was what it was one or two things in the beginning for young folks or those starting out. It's either, yeah, I understand, I see where this goes, or it's too complicated, I can't deal with this, it's making me cross-eyed, okay? But I want to cover some of the schematic basics that will alleviate some of the nervousness when you look at this crap. I mean, you look at it, it's like, what is all this stuff? It's not complicated, guys. It's about as simple as you can get. And I'm going to break it down just like I broke it down in one of my other videos a long time ago. This schematic is nothing more than a road map. Each one of these is a street. And instead of stop signs and yield signs and red lights and, right turn signs and stuff like that, you've just got capacitors, resistors, coils, tubes, and that's it. That's it. There's 4 or 5 things that make up the entire schematic. And it's either going to be east, west, north, or south. And if you can get that in your mind, you've got it made. You've already learned how to be a schematic follower. There's a difference between following and reading. I've stated this numerous times. Now, Brendan, my electronics mentor, he can look at this capacitor right here and say, yeah, here's the reason that capacitor's there. We as just, electronic mechanics, I guess is the term I'm looking for. All we have to worry about is following a schematic and making sure the capacitor's there, and if it needs to be replaced, we replace it with the same value, okay? Or a resistor, same way. Find out the value, and then replace it if it's bad after we know how to measure it. So I thought this time for this, the command decision I'm going to make is, let's do some following of the schematic as it relates to the chassis. And to show you things aren't as complicated as they might seem. For our next segment, I went ahead and took the schematic down to Office Depot, the entire page actually, and had them blow it up a little bit. I wanted a much larger blow up than what they gave me, but their machine wasn't warmed up and blah blah blah, and it would take forever, a half an hour. And I said, well, just do what you can right now, and I'll try to work with it. So they were magnanimous about it. They said, well, we're sorry, and they went ahead and gave me they blew it up to this right here, which is going to work, and they gave it to me for free because they couldn't give me what I came in there for. I was there at like 11 o'clock in the morning. I don't know what, it would seem to me they would have everything warmed up and ready to go, but they didn't. Anyway, it was nice of them to do that. I tried to talk them out of it. I said, no, I'll pay you like $2. They said, no, just take it. I said, okay, if that's what you want. They said, we're sorry we couldn't meet your needs. I said, well, you did actually. They said, just take it. It's okay. So what we're going to do, as you can see, I've gone ahead and numbered every single tube pin on every single tube, okay? 8 and 2 and 5, all the way through, Everything's been numbered. I used my tube manual for that, to include the rectifier. And we're going to do a little practical application here. Let's assume, well, let me put it this way. Eventually, if you stick with this hobby long enough, you're going to run into a radio that does not have a parts list. It does not have a drawing like this right here, where all of the parts are laid out underneath the chassis for you. It may not even have a tube layout, so you really don't know what tube you got there. It'll be minimally labeled, or it may be smudged and everything, and you can't quite make the tube numbers out and everything. It may be the best that you could find after like a couple of weeks or a month of searching. You finally found someone that had a partial schematic on a radio that, you know, really, you picked it up for a song or somebody gave it to you. It might be a old battery operated farm radio, and you decide, well, I'm going to give this a try. That's the kind of radio you should get, really, when you're starting out. It'll make you pull your hair out, but I'll guarantee when you're done, you will have learned everything practically you need to know to do all the other radios you decide to buy and repair. So I've got all my tubes numbered, and all I've got is, let me fix this page up here. And there it is. All we have is a schematic, nothing else. And even the parts aren't really labeled as to what they are. Like, for instance, even on this schematic right here, they just have you know, number 13, number 35, number 5 and 6 coil, a 38B and 18 for a capacitor. Just no values. All it is just numbers. So this turned out to be perfect for what I needed. So what we need to do is compare the schematic to what's in the radio. And keep in mind, you're going to find, if it's an old enough radio, for sure, you're going to find where someone has repaired it. Well, how do you know that? You know, if you don't have a schematic and everything, how do you know that someone's repaired it? Well, you're going to look at the solder joints. You can tell. See that mess right there? There's a classic example of a very, very bad solder joint. That did not happen at the factory, okay? Somebody's replaced this capacitor at some point, and that's how they gooked it all up. Here's another one. There's another one all blobbed up. Now keep in mind, just because the solder joint has a whole bunch of solder on it does not make it any stronger. And it doesn't take a whole lot of solder to get a good solid solder joint. And you can tell by the color and the size of the capacitors that were replaced in place of the. In this case, it was replaced in place of a electrolytic filter can that is missing from the chassis. So this is a good example of what I'm talking about. So how do we do that? Well, you know, first of all, you got to have a little bit of guts. You go in there, you tackle it. I mean, what have you got to lose? You always have to have the attitude, what have I got to lose? The radio does not work now. If when I get done, the radio still doesn't work, what have I lost? Nothing. You had a lot of fun, that's all. And of course, you don't give up. You never say that, well, you know, I can't fix it. A lot of radios that are sold on eBay are sold by guys that gave up. They either lost interest, gave up, or didn't have time, or they fixed it and it didn't work. And they just got sick of it. And they said, I'm tired of this, I'm just going to buy another radio. So I got a lot of radios that way, believe me, a lot of them. And so don't be a quitter. Don't be a quitter. Make these things bend to your will. If you're going to buy one, fix it. We fix it. That's what we do. We fix things. We don't give them away or sell them broken. We fixed them. Now, there is such a thing as unobtainium. What's an unobtainium? Well, let's say this switch right here is an oddball switch that you've never seen before. You can't find it. This is a no-name radio. It doesn't even have a name on it, we'll say. And you're going to run into that, too. Well, who made this radio? I don't know. There's no labels on it. There's no... You may only buy a chassis. You may not even be a cabinet with it. The dial may be missing, which has the name written on it for the radio, or it'll be some screwball name you never heard of. You go on the Antique Radio Forum or elsewhere, and the only thing, after a month, like I said, you came up with a schematic. Lucky you. So now we got to find out. You know, Uncle Billy, you know, the family electronics genius, you know, back in the 30s, he could fix anything. Just give me a radio. He could do it. Well, Uncle Billy, you know, he would do whatever he could to get it going, so the family still considered him to be a genius, when in fact he didn't know anything. But he gave it the best shot, and he was probably able to keep, if he kept 2 radios going out of 6, he was still a genius. That's all it took back in those days. And, you know, he could pawn it off with a lot of technical talk about why he couldn't replace it, or couldn't fix it, or replace the parts, or whatever. So that's what we're going to do today. We're going to just point at something in this schematic, or in this chassis, and compare it to the schematic. Or we can just go to the schematic. Might be better just go to the schematic. Point at something, anything here, any resistor, capacitor. See if we can find it in here, and see if it's correct. See if it's in the correct place, soldered to the correct place. So which will we do? I got to think about this for a few minutes. Alright, here we go. Our exercise. I have yet to look at these things and compare them to what's on the schematic. I wanted to look at a few other things. For instance, these switches up front here. This is your band switch, your tone control, and your on-off switch. Pretty mangy. I'm going to have to clean them up underneath here. They're nasty. So I'll tell you what, let's just go ahead and pick some stuff at random. Let's just take this red resistor. Let me zoom in here so you can see what I'm talking about. I'll just go ahead and take this red resistor and maybe this capacitor here. Or we can take, I'll tell you, this one's right in line. Let's go with the orange. We'll just take the orange, just right in line with these two. Try to find the easy stuff first. Always work on the easy stuff first. And then you can mark it off on your schematic, you know, with a highlight pen to show that you've already done that so you don't go back and do it again, all right? And so we're going to go ahead and do the orange. And maybe this capacitor, let me see. We'll do this capacitor here. This one here. It's up here in this kind of mess. So what else can we pick? What the heck, we'll do one more capacitor. We'll do this one right here, okay? And you can pick anything you want, really. You can do the red resistor, the orange resistor, this capacitor, that capacitor. Let's start with this orange capacitor and see where it goes. It's connected to this one. Let me get down here where you can see it. I don't want to get out of focus or out of picture here. This orange capacitor is connected to the red. It's also connected to this brown and green. Then from there it goes up through this capacitor here in parallel with this resistor here, and then it goes over here to the on-off switch. Okay, well that's a good key. We can start out the on-off switch and see if we can find something that is, see, body N dot, which would be, I don't see the dot on it, I can't see it, of course they put it there. It's a 1, no, body, let me see, I don't know what that is. Looks like 15 ohms maybe, I don't know. We'll have to find out because I can't tell what the dot is on the other side, if it even has a dot. So let's go to the on-off switch. Which pin is it hooked to? It's hooked to the center one. Oh, that makes it even better yet. It's hooked to the center pin on the on-off switch. So let's go to the schematic and find that. Now the problem on this schematic is finding the on-off switch. So is this it right here? No. Is this it right here? No. We're looking through for a resistor that looks like this actually. It'll be something, it'll be sort of like this. Get this over here where we can see it a little better. It'll be like that. There'll be a thing here and a thing here, and then there'll be an arrow as the slider that apparently is going to have a capacitor in parallel with it. Okay, and I don't know, this'll, you can always pretty much bet this will be connected to ground. So that's what we're looking for. A resistor with a, you know, connection on both ends with a center slider that's connected to a capacitor and a resistor in parallel. Let's see if we can find that booger on here. It's not going to be easy. The older the schematic, the more difficult it gets because the print's bad, and sometimes they don't use the same symbols that we now use, or they used in the 30s and 40s and 50s later on, you know, after the Depression. So let's see if we can find this sucker. Alright, here's our power coming in. Is that what they put the symbol down for the on-off switch? Sure looks like it, but I've never seen anything like that. Yeah, you see, there again, another problem. I don't know. Well, let's assume that's not it for now, okay? There is a capacitor, but I don't see any resistor in parallel with it. So let's keep looking. Sometimes they put them over here in the latter part of the schematic. Now there's a resistor with a parallel capacitor, but there's no switch involved. It's not there. Aha, aha, aha. Here we go. I did pretty good on my drawing. Here is a resistor with a connection point at both ends, one side to ground. Here's your center slider, and it goes up to a capacitor and a resistor in parallel. Okay. and then that runs on up to the cap on this 6K7 tube. So let's find out if there's a tap off with a grid cap on the tube. Let's see if there's a wire coming up to the grid cap on this 6A7 right here. Like I said, sometimes you'll have the tube designator, sometimes you won't, because you won't be able to read it. You won't be able to make it out. The print is usually so blurry and so screwed up. Right now, let's see if we can't find that wire going. If that's the case, then we know all of this is where it's supposed to be. So far, so good. Here's your slider right here. On the other side, away from the slider, is where that grid cap wire is connected. So let's find out what we got here. This is the wire to the to the volume control, the on-off switch. On the other side, I said, okay, this is the other side. What do we got here? Well, it goes over to a connection. A little closer here. Goes over to a connection here. Is there anything going up through the top there's nothing here going up through the top that I can see. Wait a minute. Looky down here. There's a wire right there. And where's it going? Up through a hole in the chassis. Let's see where that baby goes. Well, there it is right there. Yowza bowza. The grid cap for the 6K7. Yep, the 6K7. There it is right there. Okay, one part of the exercise complete. Alright, let's take this capacitor. I think I said this was the next one. Let's see what that's got to offer here. Now this thing here, one end is connected to ground, so that ought to be easy enough to find. And what's the other end connected to? It's connected to this bank of adjustable mica caps here. And here's another group of mica caps over here. Let's see what that's all about. Well, now keep in mind you have not much experience at this, but you can see that bank of capacitors, that bank of mica cap or variable mica caps is connected to a coil. What about this one over here? Yeah, that one's connected to a really big coil right there. I say it's connected to it. It's located directly underneath, so chances are they are connected. Now, which is which? All right, let's go back to our schematic and see if it'll help us. Okay, we've got 3 here and 3 here. So we're looking for something, 1, 2, 3, 1, 2, 3, all connected together. And the only thing I can find like that are these 3 coils here. 1, 2, 3, 1, 2, 3. I think that's it. It's got to be it. Nothing else even comes close to matching up like that. Nothing. Now let's see what else it has to offer. Alright, this coil we already showed. If you go down, it's all connected. This is mounted right up against there, so this coil is definitely part of this mess. So you come through the coil, and you'll see there's another wire. There's one end of the coil here, the other end of the coil there. And what is coming off of that coil? There is a wire, this wire with a speckle on it right there. Where does that go? Let's look on the other side of this. It hooks right there. Let's see what that is. There it is right there. It's the antenna connections. Okay. I think that pretty much solves what that is. Let's tip it back up. These will be the antenna adjustment coils, which makes that the antenna coil. Let's take a look at the schematic. There's the antenna connections. They go up to this set of coils right here. So that's it right there, okay? You hook your antenna up here, it comes in, it goes through these coils, depending on what position this switch here is in, and then it runs out through the rest of the radio. So, where's the capacitor? And we're still looking for this capacitor, keep that in mind. We now established that this is the antenna side, because it's connected to the antenna terminals. Can't be anything else. Alright, we'll see here that we've got, what do we have? We have this adjustable capacitor, that's got the arrow through it, okay? That's what an adjustable capacitor looks like. Adjustable mic, any adjustable capacitor will have an arrow through it. And it comes down, and it connects to the next one. This is all, this is coil number 1, number 2. See, these things are connected to various points in the coil. That's why it just maybe part of the way up, half of the way up, third of the way up. So you're seeing it as individual coils on the schematic, but actually it's all wound up on that one tube. So we got 1, 2, 3. So all 3 of these should be connected together with a wire. Pretty clear, huh? So let's find out if that's the case. Get this light out of my way so I can see what I'm doing. Let me see here. There's one wire back there. Here's another wire up front, right here. And of course then they're connected to here. So all 3 of those are in fact connected together. I know it's a little blurry because it's kind of a tight shot. Where do they go from there? On the schematic, you see they're all 3 connected together, and they go down to here, no, down to over here, no, that's a resistor. We're looking for a capacitor. There's a capacitor to ground. You see how easy that was? It looks complicated, but it's not. This is our adjustments for our antenna. This is the capacitor to ground. That's it. They're all connected. They're all connected together, and then they're connected to that black wire. I want you to see that black wire right there? That's the other end of the capacitor. It's connected up here in the top, goes through all 3, and then of course the other end of the capacitor is connected to ground. Was that easy or not? Let's move on to the next one. Alright, our next victim and last one is this this orange one. I think we said we were going to do, right? Okay. Well, we already know that this resistor and capacitor and see, you do it the easy way. Don't just pick at random all kinds of stuff. We're going to go over this here in a minute too before I go to the closeout segment. We already did this one. Now stay on the easy stuff. We know what this parallel resistor and capacitor is. We just came off the volume control, went on down, and we ran into this wire here. Keep in mind, this wire right here down here is that grid cap wire that goes up to the 6K7. Hang on, I gotta let my doggy out. Alright, he's happy now, so am I actually. So what is this? Let's go to our schematic. That is let's look at the value first. It's an orange, which is 3. Body N dot, keep that in mind. 3. The end is black is 0, so that's 3, 0, and then 5. We're talking about a 3. It looks like 3 megohm. Okay, 3 megohm resistor. Let's see. There's nothing on here that tells you what the values are. Keep that in mind. That's the whole point of this exercise. But it is coming off the bottom of this parallel set. So we'll go back to our volume control. We already know where that's at. See, we're sticking with the easy stuff. Here's the volume control, comes up, the center, the slider does, goes up here to the grid cap wire. There's nothing there. It's supposed to be a resistor there. Where is that thing? It's supposed to be a 3 meg resistor. We've done this, we've done that. Well, what is this line here? There it is. Now there's a 3, that's the resistor right there we're talking about. It's the same electrical point as here and here. The opposite side of the resistor and capacitor. Now this is not going to ground. See, it doesn't have the big black dot, which sometimes can be a real bear too, because they're not always labeled quite so clearly. And it's just going across and hooking up down here to these resistors here. We'll get, and if you continue on bit by bit, it takes time. It may take, I think I was, the first radio I ever did was a It was airline 165. I can't remember what it was. It was an airline, but it took me weeks to figure it out, because I was just starting on this stuff and I didn't know what was what underneath the chassis. I knew what was supposed to be there, but I really I had never dealt with old-time electronics like that, and it took me the longest time to what they call suss that out. Okay, we'll do this right here. This is our other set of coils. Now, what is that? Now, this is your antenna. What is this right here with that big old coil down in the back there? See it? Sticking through the wires, right up in there. That's a big old coil. Let's see if we can find that. All right, we already know that this is the antenna coils because we traced it all the way down to where it hooks to the antennas. And the antenna terminals right here. That was the easy one there. Now this one over here, it's a little bit different. If you're new to this stuff, you have no idea what this is. You see the coil, you see how it's hooked up, and you know it's hooked to a switch. And that switch is probably this one right here. But you don't know what it is. There's nothing labeled. Now in a case like this, this is when you go to the antique radio forum, or you have a mentor. You say, you either do a posting to the antique radio forum. If you're not a member of that forum and you're just starting out, you really should be. There are guys there to know everything. Now some of the guys really do know everything. Then you got to kind of claim to know everything and they don't know anything. So what you need to do is you send them a picture, you post a picture, or you tell them you got a schematic, you sort of scan it on your printer and ask somebody if they're familiar with this, and then you ask them what that is. You ask them what that is. And in this case, they'll come back and say, oh, well, that's a local oscillator coil. You've got your antenna and you got your local oscillator coil. Oh, okay. That doesn't probably mean much to a young guy just starting out, but this is your local oscillator coil. I used to refer to it in the antique radio forum right from the beginning as the oscillator. And some guy got on my case, John, stop saying oscillator. You know, some of these guys get picky as can be. Stop saying oscillator, that's a local oscillator. So from then on, I referred to it as a local oscillator. He was right, but I didn't see the big deal. I was more concerned with what was going on here than I was what I was calling it. But he got, he's one of those I got you guys. I got you on something. Anyway, so this would be your local oscillator coil, and it does essentially the same thing as this right here. You've got adjustable. Let me zoom in a little bit more. Over here we had the little adjustable microcaps. Same thing over here. They're all connected together and down to ground. Okay? So that's how you suss your way through an unknown radio chassis with the bare minimum of a schematic. It can be done. Don't be afraid to ask for help. You should always ask for help. If you don't know, ask for help. I'll tell you a little story. I was at work one night. We had a computer there, and I got a text. I would check my text messages or my emails at home using the computer, especially if I worked at night. I was there 12 hours all night long. I was the only guy there on the entire plant, in the entire place. And the guy contacted me. He said, John, I got a problem with a radio. I can't get it to work. I've tried everything. And I said, okay, well, what's exactly the symptoms? She said, well, you turn it on, there's nothing. So right away, that tells me there's probably something with something to do with the power supply. I mean, if it's totally dead, he doesn't have anything. So there's something wrong with the power supply here. He's not got B+. So I said, well, go to your plates and tell me what you got on. I called up the schematic on the internet on Nostalgia Air, so I was with him. And I said, check your B+ on your plates. So he did. He came back. He said he only had 0.3 volts or something like that, 0.4, which essentially told me he had nothing. And I said, well, go back to your electrolytic capacitors. You know what they are? He said, yeah, I know what they are. He said, I know some things. I said, okay. I said, check your electrolytic capacitors. Are they connected properly? He said, well, one of them is. The other one, the guy that had the radio before me, he took it out and got rid of it, said it wasn't needed. I said, really? And so I wrote it back. I said, I'll tell you what, do you have a capacitor, another electrolytic capacitor of the same value that's supposed to go in there? And I told him what it was on the schematic. He says, yeah, I got some of those. I said, well, why don't you hook it back up? He said, well, where do I hook it? So I walked him through step by step and told him exactly where to hook the missing electrolytic capacitor filter cap up. And he said, he'd come back. He said, now you sure it has to go there? This is where I've got it, right? I said, I don't. He said, yeah. And then it took about another 15-20 minutes of walking him through it. He got it all soldered up. I went over it with him a second time. I said, okay, now bring it up on your Variac. He had a Variac. He brought it up slowly. And the next email I got, I was waiting to see if it was going to work, you know. The next email I got said, "You're a genius! You're a genius! The radio's working!" He said, "I can't believe it. You fixed this thing in 30 minutes and I've been on it for weeks." I said, well, you know, the key to the whole thing was a missing capacitor. You didn't go by your schematic. Well, you know, I thought he knew more about radios than I did. And I said, no. I said, when you have a guy who hands off a radio to you and he says it's not working, everything on that radio is questionable. Everything, because you have no idea what he did. I assure you, I was no genius that night. I just, when you have missing B+, go to your caps, make sure everything in this area here is hooked up right to the transformer with the rectifier tube. This is your problem area down here. Anyway, I was very happy to help him. He said, God, he said, I'm just so happy. I said, well, good for you. Good for you. He said, from now on, I'll pay attention to the schematic. I said, thank you very much. And of course, the next thing we have to do is get our pill bottle mounted on top of the chassis. Get the wires run down through the hole and get them tacked on. That's all we're going to do is tack them on for the test. But first, we have something else to do. Like put this on there. You see? Did you guys actually think I was going to leave that blue thing on there? Oh, you guys have little faith. Give me a break. Of course I was going to do this. Why didn't you see that? Okay? You know, if I had left this on there, next thing you know, I'd be painting my transformers red. Oh! Now here's the plan for that. I don't want to be slow. I'm going to use JB Quick, you know, to glue this thing on there permanently. Now, you don't want to be slathering JB Quick around here like this, because when you push this down on there, it's going to squish the glue all the way to the bottom. Then you're going to wind up with glue in the down here in this slot, and you'll never be able to unscrew the tube from the cap. It would defeat the whole purpose of doing this. So what we're going to do is put the glue in here. Maybe slather enough around, maybe, I don't know. We're going to put it in there pretty thick. The idea here is to get the glue in this area here. So when I push it across there like that, the glue will never come all the way down into the slot. And it's got to be thick enough now, because there is a slight space between this. I don't know if you can hear that or not. There's a slight space here, so I have to put enough in there to fill the gap up in here. And I learned this, I'll tell you what, I learned this years ago when I think it was the Atwater Can 856. I tore apart the insulated, the cardboard covered electrolytic filter cap. It was a real tall one, about that tall. It was black. And the only place they put the glue was up at the top here. But boy, what a booger it was getting that thing off and getting to that can. It was, because I wanted to open it up and see what was inside of it. but you know, they only put it up here. That was kind of a happy thing to find out. I didn't want to have to, I really didn't want to tear that cardboard tube completely apart down at the bottom. I was actually able to use it over. Alright, let's whip up a little bit of glue here. I mixed up a pretty good gob, as you can see. Now it's going to take two hands to steady and everything and get that. I'm not going to put any, you know, where at the flat spot on the bottom. No, it's only going to go around the walls, just a little ways down, and hopefully it'll be enough to, you know, plug the gap between this and the plastic. I sanded down the plastic to give me a rough surface to cement to. Alright, that's what I got in there, quite a bit. Now, if any of that glue winds up, you know, maybe a spot gets on it down in this area here, you got to go in there with a paper towel or something and wipe it out. That's what happened to me, a little bit. You know, my unsteady hand, I kind of touched it a little bit with the glue that was on the screwdriver. So let me see if I can get it on there now. Well, I think I might have pulled it off. It takes about 4 minutes for this stuff to set up, so I'm going to, you know, I'm putting quite a bit of pressure between the two. I'm squeezing it together because I don't really want to see any blue around the bottom. The only thing you have to do is make sure that if you decide to do this, you can use a taller can. Make sure that the aluminum is flat. If it's wavy on the edge down here, where you're trying to fit it up against this plastic here. If it's wavy, you're going to have gaps all the way around. It's got to be nice and flat. You just take some sandpaper, lay it on there, and keep working until you get it as flat as you can. It's not going to be perfect, of course, but just do the best you can. Now keep in mind, the looks of the thing really isn't what I'm after. What I was after here was the ability to open this can without tearing it all apart. And if everything goes well, I should be able to just twist it and remove it and put it back on the opposite way. Now, of course, if it all goes to pieces, guess what? There are alternatives. Well, I'm sorry we ran out of time on this. We ran way over time, you know. You know, some guys are going to say, you know, he didn't get the radio fired up, but the schematic work was worth the trade-off. Others will say, well, I'm glad he got that out of his system. Let's move on. All right. Until next time, this is John.